Hello everyone, now we are going to discuss the next topic, that is transverse vibration. In the last topic, longitudinal vibrations, we have seen that the vibrations take place along the length of the beam. Okay, and there we have calculated the longitudinal stiffness, that was AE upon L. So what is the difference between the longitudinal vibrations and the transverse vibrations? So you can see here, I'm just drawing the diagram. There is a mass M is attached to the beam. Here, M mass, but it is a horizontal position. Okay, so there will be some deflections when vibration is going to be happen here. So a deflection is considered as delta. Okay, so I'm going to consider delta deflections. So here you have to calculate the deflection delta using the formula of cantilever beam deflection. You have seen in the strength of material, when there is the deflections in the cantilever beam at the end of the beam, what is the formula? We all know that. So you have to apply that formula in order to calculate the deflections delta. And as you are able to find out the deflections delta, you can calculate the natural frequency. Just apply the formula we have seen in the Rayleigh method, that is omega n is equal to under root of g by delta, where g is the acceleration, that is equal to 9.81 meter per second square. So here there is a mass which is going to be deflected through delta deflections. And if the position of the beam like that, that means there are two beams, so it would be like that. This is M which is going to be attached here, and this would be the another beam. Okay, so there will be also deflections like that. Okay, this would be the deflection. So the formula is same for finding out the natural frequency, that is omega n is equal to under root of g by delta. Okay, g by delta, that means first you have to calculate the delta, and you just have to put the value of delta here, but the unit must be same. If you are applying the delta, that means deflection in mm, you have to use the gravitational acceleration in also mm per second square. Okay, remember that condition. So this is the conditions when the mass is going to be attached between the beams here. Okay, you can calculate the delta value, and this is the cantilever beam. You can calculate the delta for this cantilever beam. Okay, now if in the question directly it is given that there is a stiffness of the system for transverse vibrations, then you need not to apply this formula. If the omega n is equal to under root of s by m, you know that this is the general formula. What is s here? Basically, if in the question it is given directly the stiffness of the system, this is the stiffness. This is the stiffness of system. This is the stiffness of the system for transverse vibration. Transverse vibration. Then you must have to apply this formula directly. Transverse vibration. Okay. If it is not given in the question, then you have to calculate first the delta value, static deflections. Then you have to put the value of omega n in order to calculate the frequency in radian per second. The unit is radian per second. Okay, so I hope you will understand this complete procedure. We have completed the longitudinal vibrations as well as the transverse vibrations, and torsional vibrations also we have done. Okay, so thank you.